what we can do is, let's say by writing a loop, we are calculating total sum. That we can do in one loop. So total sum is calculated using one loop. Now what we do, we take two variables, left sum, initialize to 0 and right sum. Now what we can do, let's start going over this array one by one. What we do at every element, we check if left sum is equal to right sum. Now you will ask, how do I calculate right sum? We discussed the approach that right sum is equal to left sum, which is initially 0, that is fine. So we'll say total sum minus array of 0 or array of I, whichever element we are at right now in that loop. So this is loop I 0 to n. So at 0th element, we are seeing total sum minus a of 0 minus left sum. This is how we are calculating right sum. If you are saying if left and right are equal, then return I. We are done with it. But if they are not equal, what we do, we say left sum is equal to left sum plus a of I. So what we are doing is incrementally we are building left sum and we are storing in a variable. We are not storing in an array. So what will happen at 4? At 4, if you see our left sum was 0. Total sum we have anyways calculated, which is 27. So if you see total sum of this array is 27. Now when we are looping over this, in this loop, if you try tracing, first we calculate right sum. So right sum, left sum and total sum. These are the things that we are having and we are going with I. So initially I is 0. When you are at 0th index, right sum we are calculating as total sum, which is 27, minus AI, which is 4, and left sum is 0. 27 minus 4 minus 0, so right sum is coming to be 21. Left sum we already initialized with 0, so left sum is 0. So this is what the state is right now. Then after updating these variables in this first iteration of the loop, we check is left sum and right sum equal? No. Because left sum is 21, right sum is 21, left sum is 0. They are not equal. So what do? We move ahead with I1 because this loop is going to the next level. I becomes 1. When I is 1, again we calculate right sum. So the way right sum is calculated is total sum, which is 27, minus a of 1, which is 3, minus left sum. Now left sum has become equal to left sum. Oh, we didn't update left sum. Left sum would have been equal to 4 because in left sum we added AI. So after that, we see that 27 minus 7, it becomes 20. Right sum becomes 20. Then what we do? We again compare left sum and right sum. They are not equal. So what we do? Left sum is updated to left sum plus AI. That means 4 is updated to 4 plus 3 is 7. Now if that is happening, then we go up again. We calculate right sum. So right sum this time will be 27 minus current element. Current element is going to be 1. That is where we are when I is 2. We are at element 1. So 27 minus 1 minus left sum. So left sum has become 7. So we will put 7 here. So 27 minus 7 minus 1. So it will make it 19. Right? So that is what it has become. Now also left sum and right sum are not equal. And when they are not equal, what we do in left sum, we add the next value. So in 7, we add 1 and we say 8. So this has become 8. I will become 3. We are going to the next element now. Now when we are at index 3, what we do? Our right sum we calculate. We say right sum is 27 minus current element, which is 2, minus left sum. Left sum is 8 now. 27 minus 10 is what we are getting. So 27 minus 10 will make it 17. That is the right sum. Now go and compare, is left sum and right sum equal? Answer is false. So it comes to again update the left sum. Let's move to the right. So left sum will be updated from 8 to, now we are adding 7 to it. So we add 7, 8, 7 becomes 15. Oh, sorry, I made some mistake here. 8 plus 2 is getting added now, so it will become 10. So 2 we have added because we were processing 2 right now. So it became 10 now. Left sum has become 10. We update I to be 4. Now I has become 4. So we come to the 4th index, which value is 7. Now what we do again, let's calculate the right sum. Right sum will be equal to total sum, which is 27, minus AI, which is current element. Current element is 7, minus left sum. Left sum has become 10. So what it does is it says 27 minus 7 is 20, minus 10, it becomes 10. So left right sum has also become 10. Now when left sum and right sum are equal, when these two sums have become equal, what we can do is we can return the index 4. That is going to be our answer. And imagine if no index is found, this loop will get over. Outside the loop, we can always say return -1. So this is what it will be. So ideally in this approach, if you see what we did not take any other array. Our space complexity reduced to big O of 1, and our time complexity has reduced to 2n now. Because first loop we have to write to calculate total sum. Once we have the total sum, another loop can process this. So 2n is what we have reached to. This is the best known solution for this problem. So hope this helped you. So feel free to code it. We have sent the link to code this problem in our group. So feel free to attempt this problem. There are a few tricky test cases also. Just go and handle them. And then we'll be sharing more problems on similar lines.